Hi everyone, welcome to Chempath YouTube channel. So in the last video, we have discussed about some basic concepts of solids, solid state, and also we have seen some basic properties of solids. So here let us discuss with types of solids. So these solids are classified into two types. They are crystalline solids and amorphous solids. So let us discuss one by one here. The first one is crystalline solids. So what are crystalline solids? The solids in which the constituent particles have an ordered arrangement. They are called as what? Crystalline solids. So if the constant particles are orderly arranged, then they are called as crystalline solids. So these are some of the examples for crystalline solids. They are sodium chloride, diamond, iodine, etc. So these are the examples. So this is the long and short range order which is seen in crystalline solid. This kind of orderly arrangement will be seen in crystalline solids. So next let us discuss with amorphous solids, second type. That is amorphous solids. So the solids in which constant particles do not have ordered arrangement, they are called as amorphous solids. If the particles, constant particles are not arranged properly, then they are called as amorphous solids. So glass, plastic, rubber, etc. These are the examples for amorphous solids. So this kind of order is seen in amorphous solids. That means they are not arranged orderly, and this is a short range order. Okay, this is about crystalline and amorphous solids. So next let us discuss the difference between crystalline and amorphous solids. So first difference of crystalline solid and amorphous solid is crystalline solids have definite geometrical shape. They have particular definite geometrical shape, but in amorphous solids they have irregular shape. That means they do not have definite geometrical shape. So this is the first difference. And second one, crystalline solids have sharp melting point. So at a particular point, at a sharp melting point, these solids will get melted. But amorphous solids, they do not have sharp melting point. That means they start melting from certain temperature, and for a long period they will keep on melting. So these crystalline solids, they are true solids. True solids means they are very hard, and amorphous solids are pseudo solids, or they are also called as supercooled liquids. So pseudo solids or supercooled liquid means, so now the liquids, they have tendency to flow, right? So in the same way, these amorphous solids, they also have tendency to flow very slowly. That is why they are called as pseudo solids or supercooled liquids. The fourth difference is these crystalline solids, they have definite heat of fusion. So heat of fusion means change in enthalpy, which results by providing energy. So these crystalline solids, they have definite heat of fusion, and these amorphous solids, they do not have definite heat of fusion. Okay, this is the fourth difference. And next, fifth difference is crystalline solids. In crystalline solids, the constant particles have long range order. So this is we have seen in types of solids, right? And here the constant particles have short range order. And the sixth one, these crystalline solids, they are anisotropic. So what is anisotropic? Anisotropic means the physical properties, they are different in different directions. So these amorphous solids are isotropic. Isotropic means the physical properties are same in different directions. So here the physical properties vary in different directions, but here the physical properties are same in all the directions or different directions. So again, these crystalline solids, again they are classified into four types. So on the basis of binding forces and nature of constant particles, these crystalline solids are classified as follows. First one is molecular solids, second one is ionic solids, third one is metallic solids, and fourth one is covalent solids. So these are the types of crystalline solids. So here let us discuss the different types of crystalline solids. So here we have seen four types of crystalline solids. Here let us discuss about constant particles, attractive force. Let us see example, physical nature, electrical conductivity, and melting point. So, and this first one is molecular solids. Again, these molecular solids are classified into three types, or there are three types of molecular solids. They are non-polar molecular solids, polar molecular solids, and hydrogen bonded molecular solids. So, the constant particles in these type of molecular solids are molecules. Molecules are the constant particles. Now, attractive force. So, which force is acting here? So in non-polar, dispersion or London forces acting. In polar, dipole-dipole interaction, but in hydrogen bonded, hydrogen bonding is seen. Okay. So example, argon, carbon tetrachloride, hydrogen, iodine, carbon dioxide. So these are the example for non-polar solids or molecular solids. Next for polar. In polar, example for polar molecular solids are HCl and sulfur dioxide, SO2. So next for hydrogen bonded, water. That means ice. So next let us discuss about physical nature. So non-polar molecular solids are soft in nature. Polar, they are also soft, but hydrogen bonded molecular solids are hard. And now all these non-polar, polar and hydrogen bonded molecular solids acts as insulators, or electrical conductivity is insulator. Now what is insulator? Insulator means they do not allow any heat or electricity to flow through them. Okay, so here melting point, next one is melting point. This non-polar, it has very low melting point, polar has low melting point, and hydrogen bonded also has low melting point. So next type of crystalline solids is ionic solids. The constant particles, ions are the constant particles here, and the attractive force is Coulombic or electrostatic force. Examples are sodium chloride, magnesium oxide, zinc sulfide, and calcium fluoride. So these are hard, but they are brittle, and the insulator, they act as insulator in solid state, but conductors in molten state and in aqueous solution. So when they are in these ionic solids, when they are in solid state, they act as insulators. That means they do not allow any heat and electricity to flow through them, but in conductors, they act as conductors in molten state and aqueous state. That means they allow heat and electricity to pass through them, and the melting point is high here. So next type is metallic solids. So here the positive ions in a sea of delocalized electrons, the constant particles, they are the positive ions in a sea of delocalized electrons. Then the attractive force is metallic bonding. Metallic bonding is seen here. Iron, copper, silver and magnesium. These are the examples. So these metallic solids, they are hard but malleable and ductile. Okay, so next, these are conductors in solid state as well as in molten state. Both states, they act as conductors. The melting point is fairly high here. So next type is covalent or network solids. So here atoms acts as constant particles. So next, covalent bonding is seen here. And example, silicon dioxide, that is quartz, silicon carbide, carbon, diamond and graphite. So these are hard, but graphite is soft. And these are insulators. They act as insulators, but graphite acts as conductors. And here the melting point is very high. So guys, this is about types of crystalline solids, then different types of crystalline solids and their difference. Okay, I think understood these concepts, and if you like this video, please like, share and subscribe my channel. Thank you.